Hi, this is Math 1340, and this video is going to be over section 2.3. We're going to go into linear functions, and with linear functions, we are looking at a function that has the form f of x equaling mx plus b, where m is the slope and b is your y-intercept. Right? If m is 1 and b is 0, then you get f of x equaling x, which we call the identity function, which is it's just a straight line where x and y are always the same values. And then if m is 0, then you get f of x equals b, which we call a constant function. So horizontal line, and no matter what x is, your function value is always the same. Note that vertical lines are written as x equals a, not considered functions. Definitely not linear functions. Right. So first, with the slope, again, it's m in our mx plus b. And to find the slope, we can look at it in several ways. We look at how much it's rising over how much of a run. So how much of a vertical change over how much of a horizontal change, or your change in y over your change in x. Or more formally, your change in y is y2 minus y1, where 1 and y1 is the y coordinate of one point and y2 is the y coordinate of the second point. Now it's y2 minus y1 over x2 minus x1. Right, so let's look at some graphs here for linear functions. So let's calculate it on. We got equals x, y equals 2x, and y equals 3x. Assume standard. Right. For y equals x is your first line. 2x gets steeper, and 3x is even steeper. So as m as m increases, your your line increases in slope. As m increases, the line gets steeper. Okay. So now let's look at negative 0.5x. We'll look at negative 1x. And we'll look at negative 4x. Okay. And here we see as m absolute gets larger in terms of absolute value. Larger. Absolute value. The graph. Oops. I'm looking at the one above it. It may go down to the one below it. Alright. I'll write it this way. Oops. Let me plug that in. That's the absolute value of m gets larger, the line gets steeper. And notice with this, the line having a slope that's negative, the line is downhill from left to right. All right, so one thing about the slope is we're able to use the definition of it as a rise over run to graph things pretty quickly, whether the slope is a fraction or a whole number. So here, if we want to graph 3/4 x minus 1, the minus 1 is your y-intercept, 0, -1. We'll plot that first. And then your slope is 3/4, which is 3 up, a rise of 3, and a run of 4. So you go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. You get the second point. You can go backwards on this, so we can go to the left, 1, 2, 3, 4, and down 3, 1, 2, 3. And you get another point. And you can connect those lines, or those points with the line, and you have your line graph. All we need is 2 points, and we can find the equation of the line, and we can find the slope. So remember, m is y2 minus y1 over x2 minus x1. So it doesn't matter which one's x1, y1, x2, y2, just as long as you keep it consistent. 7 minus 3 over -4 minus 1, -4 over -5, so -4/5 is the slope. Here we do x1, y1, x2, y2. You get -4 minus 6 over -3 minus a -3. We get -10 over 0. Okay, and when that happens, we are looking at a vertical line. So it's not a function at all, and we have x equals a -3. So if your x's are the same, you end up with a vertical line. If your y's are the same, you will end up with a horizontal line. There won't be any change vertically. So numerator ends up 0, and you end up with a horizontal line. All right, so let's say the number of crimes in a certain city increases from 30.4 in 1996 to 32.2 in 2006. Find the average rate of change in the number of crimes that occur. So we're looking for crimes per year. We get 2006. Here it's always best to kind of do in such a way that your time ends up positive because it just makes more sense. 2006 minus 1996 and 32.2 minus 30.4. We end up with 1.8 and 0.18 times per year. So now finding an equation. There's going to be a couple ways to find an equation. I'm going to show you 2 different ways. One that is more formal that they show you in textbooks. The other way is the way I like to do things, because it just makes more sense to me and it's a little bit easier, I think. Right, so If you want to find the equation for a line, you need the slope and you need the y-intercept. Or you can do the slope and any other point on the line. You just have to find your y-intercept. Or you can have 2 points on the line and you have to find your slope and then you have to find your y-intercept, which you can do. Right? So you need a point and you need either a second point or a slope. And it's possible to find your equation for your line. So let's say we take the slope equation, y2 minus y1, x2 minus x1, and we multiply over the x2 minus x1. x2 minus x1 equals m times y2 minus y1. No, there you go. In this case, what we're going to do is we'll let x2 and y2 be, no, I wrote that. Oh, I multiply that over. I wrote m on the wrong side. Hold on, m is on that side. I can switch sides, but multiply this over. So it's multiplying m. Okay. We're going to let x2 and y2 just be x and y. Just renaming them. Nothing more. And then we can switch the sides. You know, this is y minus y1, which is equal to m times x minus x1. Either way. And so we end up with this equation. We call it the point slope formula. So we're given point -1, 5. We can write it y minus a negative y minus 5 equals 2/3 x minus -1. We have y minus 5 equaling 2/3 x plus 1. Right. And then normally what we do from there is we solve this for y to get the slope intercept form, because that form only has one possible way of writing it for a specific line, whereas you can have multiple points on the line and write this form in different ways. So to do that, we distribute the 2/3. And then add 5 over, and you get y equals 2/3 x plus 2/3 plus 5. And then to get this as a fraction, I common denominator. So that would be, let's take that with 2/3. This would be 15 over 3. So y equals 2/3 x plus 17 over 3. So the other way of doing this is to just use our y equals mx plus b form. In this case, we plug in the point for your x and y, and we plug in the slope for your m. So we end up with 6 equaling -3 times 10 plus b. And I'm solving for b to find that y-intercept. So 6 equals -30 plus b. Add 30 both sides, you get 36 equals b. And then what you do is you take this form again and you rewrite it using y and x, but you include your slope, and then you include your y-intercept. That's your equation for your line. Okay, it's a little bit more straightforward in my mind. That's why I like to do it that way, instead of using the point slope form. Either way, though, will work. Now, this was having a slope and 1 point. If you have just 2 points, first thing you gotta do is find the slope. So 4 minus 3 over 10 minus 2, 1 over 8. That's your slope. And then you can pick either point. Now, this is what I meant by, the point slope formula. I can write that as y minus 3 equaling 1/8 x minus 2. Or I can write it as y minus 4 equaling 1/8 x minus 10. Either way, this is the same equation when you simplify it out and you solve for y. So let's do y minus 3 equals 1/8 x minus 2/8. And this one will be y minus 4 equaling 1/8 x minus 10/8. Here you're adding 3. You get y equals 1/8 x plus 3 minus 2/8. Is going to be 1/4. Let me reduce that down. And here we have y equals 1/8 x plus 4 minus 10/8, which is 5/4. Reduce that down. Okay. 3 minus 1/4 is, think about it decimal wise, it's 2.75. So that will be 11/4. Or you can change the 3 into fraction, 5 by 4 over 4, and you get 12 over 4. So you get 16 over 4. Okay. For either case, it becomes y equals 1/8 x plus 11 over 4. Okay, again, it doesn't matter which point you use, you're going to end up with the same equation. And of course, if you decided to just pick one of these points, let's do this other one in red, and do, let's say, 3 equals 1/8 times 2 plus b. This is going to be 3 equals 1/4 plus b. So b equals 3 minus 1/4 is 11. So this becomes then y equals 1/8 x plus 11 over 4. There's only one way to write the slope-intercept form. But there's multiple ways to write the point-slope form because you have multiple points on a line. So find an equation of a line through the point -6, 2 or -7. -7 minus 2. 4 minus -6. -9 over 10. Then we write y equals mx plus b. That's 2b your y. -9/10 is your slope. -6 is your x. Solving for b. 2 equals, let's see, positive 54 over 10 b. So this is going to be 20 over 10 equals 54 over 10 plus b. So b equals 20 minus 54 over 10. So -34 over 10. Which we can reduce that down, -17 over 5. Now we can write our equation y equals -9/10 x minus 17 over 5. if we're given a point. 6, 2, 3, 4, 5, 6, 5, 1, 2, 3, 4, 5, so -5 and 6. And we want to know what vertical line goes through that point and what horizontal line goes through that point. The vertical line is x equals whatever your x value is, 6. Horizontal line is y equals whatever your y value is, which is 5. Okay, the straightforward is that. All right, so now they can ask questions in different ways. Here we have f of 8 equals 6. This is basically telling me when your x is 8, your y is 6. So it gives you a point. And when your x is -4, your y is 2. The second point. So we want to find the slope here. So 6 minus 2 over 8 minus 4. You get 4 over 12, which is 1/3. Now we want to find the equation, so we need our y-intercept. So we can pick one of these points. I'm going to do 6 equals 1/3 times 8 plus b. I'm solving for b. So 6 minus 8/3 equals b. 18 over 3 minus 8/3 b. So b equals 10 over 3. Okay. So the equation here is y equals slope 1/3 x 10 over 3. And we want to know, and we can write this in function notation, f of x equals 1/3 x plus 10 over 3. And we want to know f of 0, plug in 0 for x. That's going to make that 0, you get 10 over 3. Okay. Intercepts. Okay. There's going to be one y-intercept and one x-intercept. And there's a possibility that they're the same when they go through the origin. But with a line, there's one x and one y-intercept. They're not always whole numbers. They can fall anywhere on the line. But when they are, it actually can be easy to use them to graph. So one way of doing this is to first just find your intercepts. This is easiest when your function is written in this form: ax plus b y equals some constant c. It's really easy if that constant c is divisible by the two coefficients, a and b. And we can think of this as a cover-up method. When we allow x to be 0 or y to be 0, we could essentially eliminate that term, make it something like 6x equals 12 or -4y equals 12. When we let y equal 0, we're finding the x-intercept. When we let x equal 0, we're finding the y-intercept. So first, y equaling 0 gives us 6x equals 12. So x divided by 6, you get 2. That's 2, 0. That's your x-intercept. Your y-intercept, you let x equals 12. So let x equals 0, you get -4y, 12, y equals -3. So 0, -3, y-intercept. And we can graph it just with those 2 points. The easiest way is to find 2 points. So let's say we want to graph -2x minus 3y equals 6. You let y equals 0. You get -2x equals 6, so x equals -3. negative 3, 0. And to find the y-intercept, you let x equals 0. We get negative 3y equals 6, so y equals a negative 2. Give 0, negative 2. And we can graph the point. Don't have a slope, but now that we have 2 points, we can always find the slope. It can still work if they're not, both numbers aren't divisible by, if the constant isn't divisible by both numbers. You just have to have a fraction, be able to plot a fraction. So here again, to find the x-intercept, we let y equals 0. We end up with negative 8x equals 20. So x equals 20 over negative 8, which is, let's see, 5 by 4, you get 5 over negative 2. This is going to be negative 2.5. Easiest to write as a decimal, because if it's a decimal that is a finite decimal ends, then it's easier to plot. So x-intercept is negative 2.50. Right in between negative 2 and negative 3. And then we let x equals 0 find the y-intercept. So we got 5y equals 20. So y equals 4. 0, 4 is your y-intercept. I plotted down a y. Negative 2.5. There's your line. Alright, so in the next video, we'll go more into linear functions. We'll look at parallel lines, perpendicular lines. I will see you then. Bye.